For this video, we are in Unit 4 and we're in Lesson 1, so we're looking at radical functions, and so we're graphing both square root functions and cube root functions. So we have two learning targets. Number one, we're going to be graphing them, but we're also going to be looking at some of their characteristics. So we have a ton of characteristics we can talk about. We can talk about the y-intercept, the x-intercept, and all those things. But for this section, we're really going to just focus primarily on the domain and the range, because different parts of the function itself will help us determine the domain and range. So we don't necessarily always have to graph it. We'll be able to look at an equation eventually and know what the domain and range will be without even having to plot any points or do anything. All right, so I kind of went ahead and filled in on the video just to save time so that you weren't just, waiting for me to write all of this part down. So you can always just pause and fill in the tables themselves. But for each one of these functions, what I did was I went into the calculator and I went into the table feature. So if I'll model it for this first one, but when I went into the table feature, I went to table, and because this is the square root of x, I said second x squared, which is next to the 7. So that's how I got my radical, and then I put the x. And when I hit enter, I intentionally started at -4 only because my table started at -4. So in the real world, you wouldn't have a table already there for you. You'd have to do that part yourself. But I'm trying to get you to plot very specific points to kind of keep it, the same. So I'm gonna start at -4 since my table starts at -4. All right, so -4, and then my step can just stay 0 or 1, and I'm going to keep it on auto. And so you'll notice that at -4, I have an error. At -1, I've got to scroll down some, but I have another error. At 0, I have 0, 1, 1, 2, 1.4. I'm rounding. I'm just approximating because the decimals are not going to make or break your graph. And then 3, 1.7-ish. 4, 2, and then when we go to plot these points, you really don't have to worry about the decimals as much unless you really need extra points. All right, but when I plot these points, if I plot the whole numbers, I'm going to have 0, 0, 1, 1, and 4, 2. I started off, originally when I was doing my notes, kind of doing all of the points, but I really don't need all of those points. So you can just really focus on just the whole numbers for the most part, and then only plot extra points if you really need to. Now I want you to remember that over here we had errors, so that means we're not going to have anything on this left side of the graph. So we're going to start here and kind of curve through those points. That's going to be a square root function. All right, so what you're going to hear me talk about in this video is something called a pivot point. And a pivot point is not a math term, it is completely a Hirsch term, okay? So pivot point is not something they're going to call it in a textbook or anything like that, but it kind of helps me look at my graph and figure out where everything starts from. So with a square root function, they have a starting point and then they go in one direction, either to the left or to the right, all right? So it just depends on the type of function. So this particular pivot point would be 0, 0. Another way I could get that would be to look at the original problem. So whatever's under the radical is what helps me with the x value of that pivot point, and whatever is on the outside of the radical, whether it being added or subtracted, is what helps me with the y value of that pivot point. So for this one, there's nothing being added or subtracted to the x, so the pivot point would be 0, 0, okay? And notice that's where my graph started, and then it just kind of springs from there in one direction, not two directions, only one direction. I also want you to understand that it's not a straight line, it curves, okay? So make sure that when you're doing your graphs that they curve. So for the second one, my pivot point again would be 0, 0, because there's nothing being added or subtracted to the x in parentheses, there's nothing being added or subtracted outside of the parentheses. So really, all four of these have a pivot point of 0, 0, because nothing's being added or subtracted in the radical, nothing's being added or subtracted outside of the radical. So on all of these, I entered them into my calculator and I got my table of values. All right, so I'm gonna go ahead and plot those points for that second one. I would have 0, 0, I would have 1, 2, and I would have 4, 4. Again, I'm not gonna plot the decimals unless I really have to. Now don't forget, this is my pivot point, so kind of X marks the spot, if you will, and I'm gonna pivot off of that point. It's just gonna kind of spring off of it. All right, so that's what that graph will look like. For the third one, I'm gonna plot my points again. So I have 0, 0, that's my pivot point, X marks the spot, and then 4, 1. Well, I've got a bunch of decimals in between, but I don't really need to plot those because I know that my graph is gonna slightly curve, right? So I'm gonna curve that graph towards that point to the right. All right, now before we even look at that third one, I want you to take a look at these three functions by themselves. So what's different about these functions? Well, if we look at this graph, it was just the square root of x, right? And this is what it looks like. But this one has 2 times the square root of x. And notice that this height essentially doubled. So like this is 2 up and this is 4 up. So when you have that number in the front, it's going to cause something called a vertical stretch, or in this case, a vertical shrink because it's a 0.5. So notice that it started out as 2 high, but now it's only 1 high. So it's like half the height. So that's a vertical stretch and a vertical shrink. All right, and the leading coefficient, whatever that number is in the very front, that's what determines that. All right, if you have the table of values, though, it does really help you plot points, but you still want to have, an idea of what your graph is going to look like. Now, if you look at this last function, it says -2 times the square root of x. So if I put that in my calculator, these are the points that I would get. My pivot point is 0, 0 again, but I'm going to have the point 1, -2. And what's happening here? It's not in the same quadrant anymore, right? And then 4, -4. So I know it's going to curve, start at your pivot point and pivot or curve through those 2 points. All right, so it kind of springs off, but it's springing down. So this time it's not going up to the right anymore like these ones did, right? These went up to the right. This is going down to the right. So when you have a negative in the front, it causes it to reflect. All right, so that's going to give us a reflection. Now the 2 caused it to be double in terms of height, right? So where the original started out being like 2, this is like 4 high. All right, so that's what the leading coefficient does to our graph. All right, so now let's look at the domain and look at the range. These are not negative to positive infinity anymore. All right, so because we are not going in both directions anymore, so we have a starting point, so you got to pay attention to where that starting point is. And now the pivot point is going to help us with that. All right, so for here, the domain and the range are actually going to end up being the same, but that's not always going to happen, and we'll see some examples of that in a little while. But the domain, how far to the left does my graph go? 0. How far to the right does it go? Forever. All right, so the domain here will be 0 to infinity. That's left to right. Domain is always left to right. So 0, whoops, with a bracket.
Ms. Accumulero, if you're still in the building,
to infinity.
Make contact with Dr. Murphy in the front office.
It gets a bracket because that point is inclusive. There's actually something there, right? So that's why we have a bracket. The range, how low can my graph go? 0. How high can it go? It looks like it stops here, but remember we're restricted to our paper. So it really goes to infinity. So that would be 0 to infinity. Now, these 3 right here, they're actually all 0 to infinity for the domain and the range. Because although the height changed a little bit in terms of how steep it was, it's still doing the same thing. If we continue this graph, this would keep getting higher and higher and higher. And so with this little one over here, it would still get higher and higher and higher. It would take a long time, but it would still get there. All right, so domain, 0 to infinity, range, 0 to infinity for all 3 of those. All right, I want you to understand too that on all 3 of those, the pivot point was 0, 0. 0 is an x value that's associated with domain. the y value of 0 is associated with the range. So we'll talk about that more when we have other numbers because it's a little bit easier to see that. All right, now if we look at this last one, the domain is still 0 to infinity because it can only go to 0, that's the farthest left, and it can go to infinity. But the range this time, how low can it go? Well, this time it's the opposite. It goes to negative infinity, but how high does it go? 0. So when it's reflected, it does look a little bit different. All right, so some takeaways from that. I want you to realize that what happens to the graph is the number in the front, remember that's the leading coefficient of that radical, gets larger, close to 0, or negative. So you need to know that as as that leading coefficient is bigger than 1, if it's bigger than 1, you're going to have a vertical stretch. If it's less than 1, you're going to have a vertical shrink. And it doesn't matter if it's negative or positive for that. The vertical shrink is kind of like the absolute value of 1. All right? So, but if you do have a negative, remember that negative has nothing to do with shrink or stretch. It only has to do with a reflection. All right? So those are some key characteristics to those graphs that you need to be familiar with. All right, so if we look at the next page, there's some graphs that have some different numbers, and these are helpful because it does help you see what happens. All right, now if you look at number 6, this one is the square root of a negative number. All right, so I'm going to plot some points. So -4, +2, -1, 1. Again, I'm just plotting whole numbers. 0, 0, and what would my pivot point be? It'd be 0, 0, right? Because nothing's being added or subtracted in there. So my pivot point, X marks the spot, this time I would curve up to the left. So if you have a negative under the radical, that's going to cause your graph to not reflect over the x-axis, but it causes it to reflect over the y-axis. Now, for our class, we're going to have very few of these. In fact, probably none, okay? We may end up with one more somewhere. But for the most part, our x's are going to be positive, and we're just going to be worried about things being added or subtracted and things like that. All right, but if that does happen, it would cause it to reflect over the y-axis. The domain would be negative infinity to 0, because this time it goes forever left, and it only gets to 0 for the right side. The range starts at 0, and it goes up forever, so positive infinity. Again, 0, 0 for the pivot point translates to the numbers that we use for the domain and the range. All right, so if you look at number 7, my pivot point would be -4, 0. So let's talk about that. All right, whatever is under the radical, all right, well, right here, whatever is under the radical, you do the opposite of what it is. It's because you're looking for the root. So remember how we would set things equal to 0 and solve for x, right? So that's what's essentially happening there. So the way I remember it is change it, keep it. So I change it to a -4. I keep it as 0 because nothing's being added or subtracted at the end. So change it, keep it. This is my pivot point. Notice that that's the first point that I even have anyways on my table. All right, so I'd put in my calculator the square root of x plus 4, and I'd get all of these values. So when I plot those points, my pivot point is -4, 0, x marks the spot, -3, 1, 0, 2, and 5, 3. I'd start at my pivot point and curve through those points. So my domain this time is not 0. How far to the left can it go? -4. So this would be -4 to infinity. My range, how low can it go? 0. How high can it go? Infinity. So again, those values come directly from your pivot point. All right, so -4, 0 was my pivot point. -4, 0 gave me my domain and my range. All right, so if we look at number 8, my pivot point would be change it, keep it, so 1, 0. Again, it's the first point on my table, right? So I know it's trying to think. All right, so 1, 0, x marks the spot, 2, 1, 5, 2, because I'm just plotting the whole numbers. So I'd curve through those points. Remember, it's like a springboard, so and it only goes in one direction. So my domain would be 1 to infinity. My range goes only down to 0, so 0 to infinity. Again, 1, 0 is a part of my pivot point. All right, so example 9. Change it, keep it would be -4, +3. It's hard to see that, sorry. So -4, +3, that's my pivot point. All right, so we know that's gonna help me get my domain and range in the end. So I'm gonna plot my points. X marks the spot, -4, -4, 3, X marks the spot, -3, 4, 0, 5, 5, 6 comes off my graph a little bit, but I start at my pivot point and I curve through those points in only one direction. So my domain, how far to the left do I go? -4 to infinity. My range, how low do I go? 3 to infinity. And since my pivot point was -4, 3, what do you notice about your domain and the range, right? Those numbers are the same. All right, so those are examples of square root functions. All right, now we also have cube root functions. All right, so if you look at this next example, number 10, we're on page 2, then you'll notice we have a cube root. So how we type that in our calculator, just so that you know, is I'd go to my table and I'd have to do 3 second caret. And that's what bumps it up to be a cube root of x. And I'd hit enter, and I'm gonna start at -8 since my table starts at -8, and I just keep going. And so that's where those points are coming from, all right? But that's how you type it. So this time, my pivot point, is anything added or subtracted? No. So my pivot point, 0, 0. So X marks the spot. So I'm gonna plot -8, -2, -1, -1, 0, 0 is already there, that's my pivot point, 1, 1, and 8, 2. All right, well this time you'll notice that you have points on both sides of that pivot point. That's because this is a cube root. So think about what we learned with polynomial functions, or not polynomial functions, but radical functions. If it was a square root, right, it's only gonna go in one direction, okay? But if it's a cube root, it's going to actually go in opposite directions. So 3 is odd, opposite. So it's going to go in 2 different directions. So this pivot point is going to kind of give us our spring point, like our springboard. So we're going to start here and we're going to curve through these 2 points, and then we're going to start here again and curve the other way through those 2 points. So we end up with a graph that looks something like this. And remember, it goes through both points. So that is what a cube root function looks like. Now the great thing about cube root functions is because they're going in opposite directions, the domain and the range